everyone. Welcome to another session for Global Hack Week. This is our day two. So we still have a lot of content left, and today I'll get us started with some computer vision models that are open source, which I specifically use them into robotics applications. I know the name of the stream is quite long, so open source computer vision models for robotics, which can be a bit confusing or maybe a bit overwhelming. But we will see some examples. We're also going to run some of those examples by ourselves. Then we're going to see how those actually work with complex applications in robotics, which is a case scenario from my robotics team. And then at the end, we'll just do a brief recap about other cool models that will be really interesting to use, but we won't see all of them today. So I sent the checking link on the chat. You should be able to have it in there as well. So don't forget to check in order to get your points for the weekend. Global Hack Weeks, you are basically getting points for every stream that you join, every activity that you are doing. I believe you also get points for submitting projects in Global Hack Weeks. So yeah, just make sure to check in so you can get your points and then be eligible to win some swag at the end of the week. Okay, so hopefully we can get started now. I know we are during the weekend, so it's really lovely to see a lot of people present to start building cool stuff. So, um, for the stream, so basically for the duration of the stream, we're going to do basically three important things. So, the first thing that we are going to do is we're going to go over some basic concepts for everyone to be on the same page. And then second thing, we're going to do examples for two computer vision models that are open source. And then at the end, we're going to see some examples of what is actually going on with robotics and these models. I might swap them, so we might first see the examples first and then do the examples by ourselves. So depending on how we're going, I'm going to see how to adapt the stream to see where everyone's at. So we have a question here. If we register in this end, we get the points or by submitting the feedback. So it's by checking in to the event. So on the link that I sent over on the chat, you need to check in there. And then you can also build projects. There's some projects that you can build that are also on the Global Hack Week page. And if you build some of those projects and submit them, then you will also be getting points for that as well. All right, so we're about to get started. I think I talked enough and I didn't introduce myself. So my name is Jocelyn. I'm a coach here at Major League Hacking for everyone who already knows me or you're just getting to know me. I love salsa dancing and I collect Minecraft plushies, which is really fun to see. You can ask me about mechanical keyboards, robotics, and neurotech, which are basically one of my favorite topics to talk about. I'm also into the fellowship stuff, and I'm a GitHub campus expert. So if you have any questions about that, you can also feel free to ask them during the stream or through Discord or however you prefer. Something that I like about the streams is that sometimes we have side conversations going on the chat. So if you have anything that you want to ask about, literally anything, career advice or internships or projects that you're building, feel free to drop them on the chat and we'll get to them and we will also get to discuss them, which can be really fun. So I can see more participation of hackers in the audience. All right, so this is the agenda for today. I would say that we can finish this on time. So we have roughly 2 hours, depending on how much we take on every step. So the first thing that we are going to be doing is learning about YOLO, which is the one computer vision model that we're going to be learning about. And then specifically, because YOLO has not only one model, they have a lot of different models in there. So we're going to be learning about specifically on YOLO E, which is a bit related to AI. And I know hackers get a bit excited when we touch those subjects. So we're going to be learning about that. And then once we wrap up with YOLO, we're going to be learning about a new, well, I wouldn't say it's new. It was new like 2 years, 3 years ago. But right now, I would say that the Moondream team has been doing really cool advancements in their API and open source models that they have out there. And this specific model is one that my robotics team uses um, really often to do tasks that we have to do for the competition. So we'll also be getting to explore that one as well. And then we're going to use some cool examples in robots. And finally, we're going to test our models in a simple Python code. For the Python code section, I believe we're going to be needing to download YOLO, which might take a while to run locally on your computers. If it is taking too much time, then I'll just upload the codes into a GitHub, or you can also have them for the duration of the stream and watch it later. And then for Moondream, it's super easy because it's an API, so there's no need to download everything because the models will be running on the cloud. There's also a way to run them locally, which is what we do, but I'm just going to show you how to do it through the API. Right, so hopefully after this session, you will have a zero-shot computer vision model configured. It will not only be a zero-shot, but we will also see some applications of these models in like the actual world in there. So we have a question here: how can I also become a GitHub Campus ambassador? I'm not sure if ambassador is different to the campus expert program. I've only heard about the campus expert program, which is where you get support from GitHub to do your events. So basically, they support you financially, they give you swag and prizes to support your events, and that way your community can grow much faster with the support from GitHub on all of your events. Cool. Okay, so first things first, for people that are interested on learning what is computer vision, so this is just basically a branch of AI. So there are many branches of AI, and computer vision is one of them. I would say it depends on the computer vision that you're basically applying. So for the models that we're going to be using today, it's going to be related to AI because we're going to be seeing zero-shot computer vision tasks. For people that don't know what zero-shot is, we're going to get explaining on that as well. All right. And yeah, I guess this is really general. So computer vision is just basically interpreting and understanding visual data like a person does. Of course, a camera or a robot won't directly identify what it's seeing, so you have to train it and you have to tell that object like, oh, you want to see, I don't know, like persons walking on the street or cars, and you have to train that specific model in order to recognize all the objects that it's seeing on its day-to-day basis. So that is the traditional computer vision models. And then we have the zero shot models where you can actually do prompts and get those things identified on your image. So for example, if you have something super specific, let's say, so I have like this bottle of water, which might not look like a generic water bottle. It has metal and it's blue and it has some wavy forms in here. So instead of saying to the model like, "Oh, this is water," you can do a prompt and just tell the model like, "Identify a metal bottle that has a blue cap," and then it will identify that specifically on your image, which is really cool. And you'll get to see it in a second with some examples that I prepared. And I think there's also a video that shows the model working in real time. Okay, we have some hellos in here. That's great to see. We have a question. Are there any more robotics workshops planned? From my side, there's one more, which is actually more specific. So it will be happening tomorrow. It's the one that's called Getting Started with ROS 2 for open source projects. So ROS is robotics operating system. So if you're into robotics and you want to learn how this system works, make sure to check in for the stream tomorrow, which will be happening tomorrow, I believe, at 1 p.m. CST. But yeah, that will be happening tomorrow. I'll also be giving that one. I would say it's going to be a bit challenging to make it simple to understand, but I'll make sure to prepare cool content for you to understand easily. And ROS is actually one of the standard models. Well, not standard models, but standard operative systems that we use in robotics to basically communicate everything. So if you want to learn about that, make sure to join for tomorrow. And yeah, as part of the Global Hack Week streams, a while back, I was only giving streams about APIs, building apps, using some AI models, and things like that. But recently, I'm taking the task of doing more robotics streams because I know there's a lot of hardware people out there. I actually gave some really cool streams on the like 2 Global Hack Weeks ago, where did our first assembly code, and then we also learned about cool controllers like STM32 and FPGAs as well. So that was really cool. It was also a while back, but I'll make sure to make more for the upcoming Global Hack Weeks. We have a question here. Recently started a project using Neural Engine 5, ROS2 to train C computer vision models and multi-agent reinforcement learning. So this is perfect timing. We'll love to collab. Oh yeah, definitely. For tomorrow, I probably won't be getting too far on ROS2. So we'll be basically seeing introduction and what are nodes, what are services, and how to communicate between them, and how to actually download ROS and like run some example commands on our terminal. So yeah, definitely what you're doing is way more complex. But yeah, definitely feel free to drop by and ask any questions that you might have. How YOLO is different from Open CV? That's a nice question, and we'll be getting to that on the upcoming content. That's amazing. Can we get your LinkedIn, please? I'll have to search it, but you can look me up as Jocelyn Velarde, and then you should be able to find me in there. I think in my headline I have something like MLH coach or something. So you should be able to identify me from there. And Moondream API is free. Yes, this API is completely free. There's no need for you to purchase anything. I love to collaborate. I've been using LLM-based agents to control rovers. Oh, that's really cool. LLM-based agents to control rovers. Can you tell us a bit more on the LLMs that you used to control the hardware that you're using? I think that will be really interesting to know. Okay, I'll be moving on, and then I'll continue answering your questions in there. Awesome. So some of the key tasks in computer vision are some of this, which are examples of how people or applications use computer vision. So the most common one is image classification. So you can identify objects. You can identify between stuff. So for example, you can classify between cat or dog or water bottle and orange juice, things like that. And then you also have object detection, sorry, with bounding boxes. So I would say that one is the most common one, where you see the bounding boxes around an object. And then there's also pose estimation. This one is not very, most people don't associate pose estimation with computer vision, but it's actually really related. Because sometimes, for example, in the robotics competition that I participate, we need to do pose estimation in order to detect if a person is raising their hand, or if the person is waving, or if the person is giving a thumbs up. So pose estimation is actually really a really important branch for computer vision in there. Okay. And then for facial recognition, that one is another one. So facial recognition is to basically differentiate between different individuals, or you can also differentiate different expressions. So I remember a while back, I did a project on computer vision where I had a camera in the classroom and it was detecting the faces of the students. And whenever a student was getting like a bit overwhelmed or stressed, or maybe his face or her face was like frowning, with the eyebrows like being a frown, So the computer vision model would actually detect if the students were getting stressed, so the professor could actually change the course of the class or do different things in there. Okay, and then after that, let's see what we have next. So here's a basic example of the differentiation between classification and object detection. So one thing is actually knowing what a cat is, but then there's another part of detecting if it's a cat, if it's a dog, or if it's a dog in here. So we have more images in here. Object classification is just knowing that this is a person, and then object detection is actually doing the boxes and saying like, oh, this is person one, this is person two, and this is person three. So there's actually a difference in there. And then we also have another image in here that is called semantic segmentation. So segmentation, it's not only having the bounding box of the object, but it's also actually cropping the shape of the object so you can have the object more precise and better identified in there. And then after doing semantic segmentation, you can do instant segmentation. So there are some cases where you don't only want to detect like, oh, these are cars, but you want to detect this is car number one, this is car number two, and this is car number three. This is specifically useful for detecting different types of persons. So, for example, in our robotics team, our robot has to identify different persons, so it can deliver the correct messages to the to the person that the robot is actually seeing. So it has a way of knowing who each person is to deliver the correct information. And by doing that, we are basically doing instant segmentation. So we can basically have an ID associated to each image that, well, not image, to each person that we classify. Okay, so let's see some comments in here. How will model tackle if bottle is blocked up to 75% by another thing, like a person's hand? I would say this completely depends on your training. So if you're using a regular open source model like the one that we're using today, it probably won't be really good. But if you do custom training, so for example, if you take images of the objects and then like if you blocked, like if you take images like this and then tell the model that this is a water bottle, it will detect it correctly. But you need to take many pictures and you also need to transform those pictures so you can have a variety of images to train your data set. So as long as you have enough data to train your data set and you consider different cases that can happen, like blocking stuff um, on your detection frame, you should be good. Um, because there's some cases in the competition where we have many objects and there are different objects in front of each other. Like for example, you can have your water bottle and then you can have another container that's blocking its way. So you need to be able to identify those objects even if there's something blocking the side. Of course, if you have something that is completely blocking the object, it will be almost impossible to detect that because even you as a person won't be able to detect that there's a water bottle in the back of that large object that's blocking the way. So it all depends on how you do your training for the models and how many images and if you're using the correct images to train your model. Where can we see all of the workshops? So all of the workshops, you can find them on our YouTube channel. So if you go to the MLH page on YouTube and you go to lives, all of the live recordings are uploaded automatically at the end of each stream. So if you want to go ahead and search other robotics workshops that I've given, you can definitely look into the assembly one. I believe the assembly one has two parts. I recommend seeing part number two because it has really cool insights. But yeah, you can see all of the historical streams and have been going on throughout the courses of MLH's lifetime. So it's really cool. Um, schedule actually bookmark this because I couldn't find it again. Here you go. Yeah, in there you can actually see all the streams that will be coming up. So the ones that I mentioned that are on the YouTube, those are the ones that are already passed. And then on the Global Hack Week schedule, you can find the ones that will be happening on during this week. Okay, that's really cool. I missed the Tetris match and I was so intrigued to play too. No worries. I'm pretty sure there's going to be more mini events going on. I believe there's one. Let me see if there's one tomorrow. I think there's one tomorrow. There's one tomorrow after my stream, actually at 6 p.m. It's a Scribble .io mini event where you get to draw things and then people have to guess what you just draw. That is one of my favorite mini games to play. It's really cool. Can yellow be used for optical character recognition? I think that's I think that's something that Moondream can do. I would recommend strongly YOLO-E for detecting objects or specific things on objects. So if you want to detect something that is really niche and you don't want to train your whole data set, then you can use YOLO-E. But for character recognition, I would definitely use Moondream, and you'll see why. There's really cool applications of Moondream for character recognition, and I think it has now launched the third version of its model. So there's more things that we will be learning about Moondream. But yeah, I would definitely not use YOLO for specific application. I'm entirely new in the robotics field, but I hear Arduino is mainly used. What's a coding framework for an AI integrated robot look like? Okay, so basically, I would say Arduino is for learning basics and getting you introduced into all of the things that are related to hardware, how to connect your microcontroller, how to plug in all of the cables, all of the pins, the motors that you're going to be using, the sensors that you're going to be using, uploading your code. So getting familiar with a small implementation of what robotics is, but then when you go actually into the industry and see bigger applications of robots, it's very likely that you won't be seeing Arduino out there. So most commonly for high end robots that do many things and are basically autonomous, we don't use Arduino. We you can basically do you can basically use different controllers in there. So one of the most common ones is STM32, or you can have Raspberry Pi for smaller robots that don't require many computer processing. And then if you require having large AI models downloaded or run local stuff really fast, you can also use NVIDIA Jetsons, which are they are more expensive for a average hacker to purchase. But if you're in a robotics team or in an investigation line, it's very likely that you will be interacting with those, which are basically just supercomputers where you can run things and you can run all of your models and you can access through them, doing SSH or accessing through a local server that is up there on that computer. But yeah, I would definitely recommend searching about those so you can just see what they are. But it's starting with Arduino is basically the first step that you need to do for getting into robotics. And once that you master Arduino completely, then I would recommend for you to move on to more advanced microcontrollers. Okay, let's move on to the next thing in here. So there was a question back there about the difference between YOLO and OpenCV. So here are some of the common tools that are used for computer vision. So OpenCV is for doing stuff with the images. So, for example, if you want to transform your image, or if you want to crop it, or if you want to change the RGB color palette, if you want to change it to more like to grayscale, or different filters that you can apply to images for your computer vision models to identify the images correctly, you can use OpenCV, which is which is mostly used with YOLO as well. So YOLO, it's basically a toolbox for object detection. So in YOLO, you can identify objects mostly, and you can pre-train your models as well to identify specific objects of your choice, which is very different to what OpenCV does. So OpenCV is mostly dealing with the images and playing around with the images, so you get a better result. And then with YOLO, it's just basically a specific model that detects objects in real time as well. There's also other two in here. We have TensorFlow for deep learning, and then we also have Hugging Face, which is basically it's like a hub where you have different pre-trained vision models. We're not going to be seeing plenty of examples of Hugging Face. I've done some streams back then with Hugging Face, but it's just basically like a hub where people upload their own models, and then you can actually use them and play around with them as well. That's just basically some of the common tools that we use. So now getting into YOLO specifically. So the definition of YOLO, it's basically you only look once, and this is a real-time object detection algorithm. On the backside, so the backend architecture of this, of how it works, it uses a single neural network to perform the classification and prediction of the bounding boxes. Because to run YOLO, it's not really hard. So you just you download the model, and then you start identifying objects super easily. Um, and yeah, so you just start running them, and you can identify them much more easier from there. Let's see what's next. Okay, and then about understanding how it actually works, so how YOLO actually does the whole stuff. So this is actually more, this is more interesting, okay? Because you are going to be understanding how YOLO works on the backend structure. So if you get to use YOLO, you would know that it's just downloading a model and then just running it directly on your Python code, and it will automatically start identifying stuff. But to actually understand how it works, you need to go through a specific process on how it detects the images. So the first step that it takes is that it has an image. So it has an input, which is, for example, we have a dog in here, and then we also have a bike on the back. So the first thing that it does, it segments the image into smaller images. So in here we have an S times S grid on the input. So you segment in there and just do all of the lines to, divide them into smaller squares. And then the second thing that it does is that each cell on the grid that we have, so the individual squares, is responsible for detecting objects whose center falls inside it. So for example, each cell predicts B bounding boxes. So let's say that, for example, in this image, if we segment this, then like on the upper corner, then we won't have the zebra because there's no zebra in there. So if we were to detect a smaller square that's on where the zebra is, then we can actually detect that the object actually falls into that category in there. And then the third thing that happens is that each bounding box is defined by different attributes. So we have X, Y, we have width and height, and then we have confidence as well. So the most important one is confidence because it's how the model knows, like the percentage accuracy of that being the object that you want to detect. So let's say in here we can have confidence 0.98 or 0.72, depending on how high is the confidence of detecting the specific object in there. And then the third thing, the fourth thing that happens is that there's this thing called intersection over union, which is just basically overlapping all the detections that you gave and having a perfect match to know where your object is. So it's basically finding all of the S times S squares that cover your object as a whole. So in here, we are seeing that the dog is covered by these squares. So we are like super sure that the object has to be in the intersection of these two boxes that were detected. Okay, and then again, each cell, so each individual square that we have has different values. So it can either have a single class, and we can also have the number of possible object classes. So in here, we have this grid of the dog, and then we have, I know this can be a bit hard to understand, but there's different vectors that are detected on each small square. And I'll be getting into what a vector is in relation to object detection in a second. But for now, you just need to know that each square has different arrays of stuff that it's actually plugged in there, so you can detect what the image is actually about. And if you go think about programming related to math, it's actually pretty much related. So this is when we are actually getting into the hard stuff to understanding how these models work on the backside. And here's another example of the values that the object actually has. I'm not going to go super deep into this, so just for you to know that there's some calculations that are being done in order to find the actual bounding box for the object that we are seeing. And then finally, here is how the model actually calculates the height and the width of the bounding box. Because if you see one of these models, you will notice that it actually gives you a bounding box or of where the object is located. So this is how the process actually works and how it actually calculates that this is a dog over here. Okay, and then here's just a general overview of all, like a summary of all of the stuff that we basically saw about YOLO. Awesome. So after learning about YOLO and how it actually works, you don't need to understand it completely. I mean, honestly, it's something that I learned like super. That was really new to me. To use YOLO, you don't need to understand all of those things. But if you want to train your own model and you want to know how it works, then it is important for you to understand those types of things. All right, and then we have more questions in here. How many images will I need for that bottle example? Also, how long would this fine-tuning process take? Fine-tuning LLM takes a long time. Does YOLO take long as well? Um, so yeah, it basically takes a while. For example, to train, I would say not really confident, but have a nice data set. I would say 500 images is good. But you can take less images and you can then transform those images using different libraries like OpenCV as well to transfer your images and generate more images from there. And that process is called data augmentation, which is basically taking the images that you have and then transforming them so you can have a larger data set in case that you don't want to be taking so many pictures in many backgrounds and many lighting scenes. And then as for how many time it takes, I would say it completely depends on the computer power that you have. So let's say that you have an average computer where you're running your models, like you have your graphic card, I don't know, like a 4070, and you have an E7, perhaps you have 16 gigabytes of RAM. I've seen those cases, and it takes around, like for a data set of 10 objects, it can take from 2 to 5 hours. So it's definitely not going to be quick because there's many images that you have to go through. So I would definitely allocate an average of 4 to 5 hours to train. Again, it depends completely on the computer power that you have. Because if you have better processing, then your model will be trained faster. Then we have another question here. Are there any particularly elegant examples you can think of combining OpenCV and YOLO to do something neither could do on its own? To do something neither could do on its own. Oh, like combining them to do like something really cool without like dividing them. So usually both of them are used together for most of the examples because you're not going to be just giving the images like they are. So you need to pre-process those images first before like giving them to your YOLO model. So I would say they always go together. I mean, for complex examples, at least where you want to pre-process your images first as well. Okay, and then moving on to zero shot object detection. So this is, I would say this is related to YOLO because we're going to see the zero shot object detection model of YOLO, which is called YOLO-E. So this is basically a technique that allows the model to classify objects from previously unseen classes. So what does this mean? I don't need to train my model to know that this is a water bottle because my zero shot model will basically know it is a water bottle because it is a zero shot model. And this is very useful specifically for autonomous systems. Why? Because you won't have control of everything that your robot is seeing. So if you are in a controlled environment where you know exactly which objects your robot will be seeing, then it's okay. There's no need for you to do zero shot object detection. But if you're actually out there, like in the real world, then you will actually need a zero shot object detection model so you can identify classes that you've never seen. So these models actually allow you to identify stuff that you don't have knowledge of or that you didn't train any model for in there. Okay. And how does this work? So this is a bit simpler to understand, specifically if you are familiar with AI systems. So you need to divide in three categories your data set. Well, yeah, you need to divide your data set in three categories. So the category of seen classes, the category of unseen classes, and then some auxiliary information, which is the semantic information or word embeddings. So those of you who are familiarized with AI and what embeddings are, so embeddings are just basically the representation of something in a numerical vector that a model can understand in order to make specific assumptions. So embeddings are actually highly used in the AI, well, in the LLM world to do all of the actual prediction and recommendations to people. So of course, this also has to do a lot with AI and zero shot as well. Those synthetic data play any part in any of this, or I way of course. So if by synthetic data you mean like having artificial versions of your image itself, like for example, we can have this image of a cat that I took and then change the background to different backgrounds so I can have more data. Then yes, that is synthetic data for me. I don't know if you meant something different, but for me, synthetic data in computer vision is basically creating more versions of your own image using specific libraries so you can have a bigger data set to train your model. Okay, and then how does zero shot learning actually works? So you as a person, you are able to do a zero shot learning because of your existing language knowledge base. This might sound very technical, but for example, if you travel to a place that you've never been before, and then you see perhaps an animal that you've never seen before, you can say like, oh, this animal, it's similar to a dog, but it also has it's also is similar to a tiger. So you can start making assumptions to guess what this new animal that you've never seen before is actually um, is to identify like that image of the new animal that you're seeing. And for zero shot models is basically similar. So depending on the actual knowledge base that these models have, they can make their own assumptions to identify the new image that it has. So here's a nice graphic example of how this works. Oh, sorry. So for example, in our model, we have a giraffe in here. Then I think we have a goat, and then we also have a horse in here. So then when we see a new animal, which is a sheep, then we can place the sheep somewhere in here because it's not highly related to a giraffe. It's not a goat exactly, and it's neither a horse, but it's somewhere in between um, with the goat and the horse. So that's why the sheep is classified in here. So this is actually how zero shot learning works. So you see a new object that you've never seen and you try to classify it into the category that it mostly fits. And you can also start creating like new classes from there. And this is where the whole role of semantic embeddings takes place. So semantic embeddings are just basically vector representations of class labels or descriptions that cause meaning on a high dimensional space. So this is a pretty this is a very it's a very complex definition for people that never heard about embeddings. But embeddings are just basically numerical representations. So as they are numeric representations, you can actually plot those points into a two-dimensional space, as we are seeing in here. So for example, we are seeing that the apple and the pear are most likely to be plotted near each other. And then for a bottle, those I mean, it's not very similar in here. It's not a fruit, so that's why we're placing it on a much further space. And then, as we're seeing here in the image, for example, semantically similar, and they're also not visually similar. So the pear is not visually similar to the apple, but they are semantically similar. By semantically, I mean that the definition of those objects is basically similar. So an apple is a fruit, and a pear is also a fruit. So that's why they're semantically similar. But then for the bottle, it's semantically dissimilar because a bottle is not a fruit. It's not something that you can eat. So that's why it's not similar. But then it's also visually similar because the pear is also kind of yellowish, and then the bottle is also kind of yellowish, and it's also long. So that's why they are somewhere alike in there. And this is how you can start classifying objects. Like you can say like, oh, we have our object in here. Is this a food or is this an artifact? And you can start making different classifications down there from what you're actually having in there. Okay, so let's see what we have next. Awesome. So now that we saw about computer vision, that we learned about zero shot models, we're going to start learning about what YOLO-E specifically is. And let me just check the chat. Please, can we receive the slideshow file? Yes, I'll be sending this at the end of the stream. If I forget by some case at the end, just make sure to remind me, or you can also ping me on the Discord so I can send it to you as well in case I forget at the end of the stream. All right, so now to move on for the now to move on for YOLO-E. So this is actually it's not a really new model. I think it dropped like 1 year ago or so. But YOLO-E it's basically a zero shot promptable YOLO model designed for open vocabulary detection and segmentation. So you can identify objects, and then you can also identify them from there. Okay, just give me a moment. Yeah, because YOLO-E was it's really new. I remember we were participating on this competition, and then we found out about YOLO-E, and then we wanted to implement that right away because we have our own computer vision pipelines, but then it's also hard to identify objects that you've never seen or things that the model is not really well trained for. So that's why it's really cool. Okay, let's move on. Oh, okay. Let me just open up this video because I think it's really important for you to watch at least the small section of this. Let me just open this up. And let me share my other screen. We're not going to watch like the whole video. I'm just going to show you how it actually works so you can have an idea before I start explaining this. And then I'm going to pause it to explain some things in there as well. Okay, so So in here, this guy is basically saying that with YOLO-E, you're able to identify anything that you want as long as you give it a prompt, which is really cool. At least in my opinion, this is really cool because you can, for example, let's say, um, So I have this keychain over here, which is kind of a small geese. So I can tell the model as a prompt, like, oh, this is a keychain of a geese, and then the model would automatically detect a bounding box over it. Then we have a comment in here. His voice is not audible. Let me check if I can share you audio. If not, we can see the caps in here. Let me try again. Mm, I think I need to share my whole screen. Let me try this again. Oh yeah, I think this will definitely work. There we go. Awesome.
Need to go in and fine tune our models on our own custom data set, but this is really good for use cases where we just want to detect arbitrary objects. We can even prompt it, give text descriptions of what we want to go in and detect in our images. So just jump straight into the Autolytics documentation. If we go inside the model tab, we can see all the models that we have available. If you're familiar with the YOLO world model, it is kind of like similar to that. It's just a newer version and does a very good job. At the bottom, we had the new model, the YOLO E, real-time seeing anything. First of all, we're going to have an introduction. We can see we have text prompt, visual prompt. So this is actually like, and also prompt free. So just detect anything that you can see in the images. A visual prompt is basically just where we give it an image, we give it a reference, and then it's going to detect similar objects. We can also give it a text prompt. So we just prompted, I want to detect rocks, trees, rivers, animals, whatever object that you can see in the image or are interested in. First of all, you can read a bit more about it. It has some improvements over the, not only because we can just prompt it or give it examples, tons of details covered in here, but let's now jump into Cursor, my code editor. I have a few videos that we're just going to run through. So we have this indoor environment of a living room from multiple different angles to see if it catches that. We have a video here with some animals, and we'll have this guy riding on top of a horse. I have a script. I basically just took the user example from the Autolytics documentation. It's just a few lines of code, but here we also see how we can extract the results if you want to use it in your own applications and projects. So the first one.
We're actually going to use this code from the own documentation to run it. I think I can run it in my computer. I'm not sure if I have those models downloaded, but I will try. But yeah, all of these examples are in the documentation that I'm going to show in a second. And this person over here, he's basically going to show like different videos that he has, and then he's going to try to identify, for example, the camel walking and then also the black horse without actually training the model by himself.
Here is the prompt free. It's just going to take everything and detect that. The second one is going to be a text prompt where we can guide it to 5 models pretty much at the same time or without doing anything compared to just having to change out the models, set up new frameworks, set up new code bases to be able to test out models. This is significantly faster if you're doing like proof of concepts or basically just whatever you're doing. This is the easiest way by far. So right now, let's actually go in and try to just run the code. So right now we have the boxes. So that's gonna be our like this. Let's get an error. There we go. We have a model, we want to predict, we want to show it while it's running inference. We're also going to save it to a video file, and we want to show our confidence score, or we actually set that to false, but you can set it to true, and it's going to show the confidence score as well. This is a video, prompt-free video. It's going to be the indoor environment that we pass it through first. The runtime time could be your project or your own script. We hit in the directory, it's going to do it automatically. There we go. Now we see we get a chair, kitchen table, we get a carpet, we even get the carpet with a very nice.
So in here, we're basically seeing how it's detecting in real life objects that the model was never trained on. So if you see in here on the video, there's super specific things like the picture. There's also the buffet in here, the house plant, lamps in here, house plant over here on the backside, kitchen table. So these are things super specific, and it just basically gave a video of it, and it's actually detecting all of the stuff in here, which is really nice to see, to be honest. And this is basically the prompt free version. So this person is not giving it a prompt; it's just telling the model like, "Oh, detect everything that you can from this image." And then, well, from that video. And then if you actually want to detect specific things giving prompts, then you are also able to do that. And I think he's going to run those examples as well.
A segmentation mask. Under, we
Let me
have the
see.
chair, we have like a cocktail table, carpet, switches a bit back. So trying to just run the other example that we have as well. So we both have the prompt free, just gonna detect everything. Let me comment this out. Will. So we have the two examples. First of all, just do the camel walking.
So in this second example, he's just going to give it a prompt that is detect the camel that is walking, and then he's going to pass on the video that he has.
Set the classes, model set classes, and then in our remember to set the classes here, it's basically just gonna be a need. So we also need clip installed. So it's automatically gonna install clip and run
This library that's called Clip, that one is the one that takes a really long time to download. So yeah.
it after. So now we can see that this is actually like almost a 600 prompt with the detections that we're getting from the model. So now after it has downloaded the model, we can see we have these camels walking around. We get a pretty nice segmentation mask around it. Now we're also showing the confidence score, so that can be very useful as well. You can go in and do confidence thresholding. So if it's below some confidence score, you can basically just filter them out. Now we can see when it's occluded, it has some problems. Sometimes it gets it, sometimes it misses it. We'll see this camel is coming in on the right side.
Okay, I think that was enough for the video. We basically see um, how cool YOLO is. That you can basically literally see anything that you want just by giving it a simple prompt, or just by detecting things that you have in there, which I think it's really nice to see as well. Okay, so what's next? Let's see. Okay, so before going into the Moondream section, I think it will be nice to see the YOLO E example that we had before, right? So I'll just stop sharing this one. And I'm going to go and show you the YOLO E documentation in here. So let's go with YOLO E. There we go. So this is the official documentation page. Let me share it with you as well. There we go. So this is basically what the person was seeing. Let me see if I can make this a bit bigger for you to see. Wait. Um, there we go. Oh, hold on. Uh, okay, there we go. I think my computer lagged for a second and I had to refresh my page. So let me share screen back with the YOLO E stuff. Awesome. There we go. So for this section, it has different applications in here, as we were seeing. I think the coolest one is the prompt free version, which is this one, which is basically detecting like super random things on an image. And here is basically an image of a table with many things. So it's detecting super specific things like berry, fork, cranberry, which I think it's really nice to see. Okay, and then here's the video that we just basically saw. Here is the architecture overview. And then here are some of the models that you can use, which are text and visual prompt models. And then here are the prompt free models that you can download. I think I have this one downloaded. So let me see if we can find an example from here. So prompt free. Let's try this one. Yeah, let's try this one on my local in here. Vision.py. Oh, I missed the P. And let me make this bigger so you can also see. Oh, I wasn't sharing my coding tab. Hold on. Um, there we go. So I just basically created a simple file that's called vision.py. You can follow up and do it as well. But again, I'm just basically copy pasting the example from the Ultralytics documentation, and I'll see if I can run this without having like anything downloaded. So instead of using, let's see, YOLO E11, else segmentation, PF. I think this one is the correct one. And then I'm just going to change the path to my image, and I'm going to call this plushie. There we go, GPJ. And then show the results to see what we actually detected. So let's run this Python vision.py. And let's see. So it detected these things. Oh, wait, it's not actually showing. Let me share my whole screen so you can see it. I think I was sharing like just one tab, so let me share the entire screen. There we go. So I had this image. Let me actually show you the original image. So this is the original image that I had. And then this is the image that the YOLO-E version gave me, which is detecting a person in here and then a chair, which is strongly accurate. So there's actually a person in here. And then the Octocat, it's detecting it as a teddy, as a teddy bear. And then there's also a work bench in here. There's also a chair. The man has some glasses. And if you see, this is really cool because if you see closely, the image is actually blurred. So it's really impressive to see. All right, so let's try to find another cool image. So let's see a messy kitchen table. Let's see if we can find a messy kitchen table to identify like plenty of things. Okay, I think this one is. Honestly, it's really gross. Let's try to find something better. Um, food buffet because I'm hungry. So let's see food buffet. Um, hmm, this one Loki looks good. Okay, this one has many things in here. I mean, but to be honest, I don't even know what this is. So I'm not expecting the model to know what it is as well. Let's see if there's something like with drinks or something so it can detect it better. Probably this one, huh? This one has many things. So let's download this one. Let's call it food. And then let's go back to our code in here and let's just drop that new image in there. Food. So now we will be doing the text, the free prompt in here. So I go back to my code and just changing heat to food. And let's run this again. Oh my god, there's many things on here. So there's a meat, then a cucumber in here. There's many plates apparently. It also has a cutting board. That was really specific. Bowl, appetizer, lime, pizza. Is there an actual pizza in there? I don't think so. I don't think there was a pizza in here. Okay, so as you can see, the model basically identifies like literally anything that you gave it. And this is very specific for cases where you are not familiar with the external environment. Okay, so let me close this up and go back over here. So this is the actual documentation for YOLOE. You can go ahead and play around with some other examples. So there's also text prompts where you can identify like the different classes that you want to classify. And then you can also have a visual prompt where you give it like an example of the object that you want to detect, and then it will actually try to detect it by itself. All right, so now knowing when to apply this, so let's say that you have your robot and you have your pre-trained model, so you have your computer vision model, but you don't want to there are some things that maybe your main computer vision model won't detect correctly. So in that case, you want a zero shot prompting model in order to rescue when it's possible and detect using whatever the model can basically identify from there, which is really helpful, to be honest. So let me now load the slides again so we can have it in here. Let me move this. Okay, so far we've covered many things, to be honest. So we've covered computer vision basics. We covered what zero shot. Then we made usage of this zero shot model, which is YOLOE, which you can also go ahead and try it by yourselves. I send you out the documentation in here where you can find the code. Just plug it in into your Python code, and then it will ask you to download. You need to download the model that it's in that page as well, and then you also need to download clips. Clips will download automatically the first time that you run the code. It will basically take you a while to download that. Just it depends from computer to computer. Okay, so before moving on, for the to the second section of the stream where we will be learning about Moondream, I'm going to give you all a short break of like 3 to 5 minutes, so I can just go grab more water, and in case that you want to download this model, let me just show you where. So in case that you want to download the model so you can try it by yourself, you can download any of these models and then just change the name and add it into your VS Code environment so you can run it as well from there. All right, so I'll see you in about 5 minutes to continue with the Moondream section. Okay. Hey everyone, I'm back. Let me remove this banner in here and check for any questions. I left for a second. What's happening? Oh yeah. So basically, I gave like a 5 minute break. If people wanted to run the code by themselves and also download the model and try it out, because I know it can take some time to download. But yeah, we're back from that break, and I will be moving on to the second part of the stream, which will be about learning about Moondream. Hi, greetings from India. Nice to see you here. And yes, there was a 5 minute break, and yes, I'm back now for to see the Moondream section. Let me remove this and add this one in here. There we go. So Moondream basically, it's an open source visual language model. So it's a bit similar to YOLOE, but it has different capabilities. I remember at the beginning of the stream, someone was asking if you can do character detection with Moondream. I'm sorry, with YOLO. And with Moondream, you can actually do it. And I'm going to show you the documentation in a second. So you can see all of the different capabilities that you can do using Moondream. So there's no training needed. It's just a model and a prompt that you can use to test it out. So some of the cool tools that Moondream has is visual question answering. You also have image captioning. You can have object detection with bounding box, and you can point in X, Y coordinates. There's also gaze detection and document and text understanding, which is related to the character detection. So these are some of the capabilities that I know exist, but I'm pretty sure Moondream just dropped some new capabilities. So we'll go and check if there's any update on their page so we can see it as well. And yeah, before going into the comparison, let's actually go ahead and see the documentation. So this is actually very specific for robotics, you know. It's powerful visual AI. Moondream is an open source visual language model that understands images using simply text prompts. And then this is really cool. Find the grasp points. This is actually really nice. Let's see what's next. A cashier is grabbing the wine bottle is being put in a bag. The bag says Lamarge. Up here has been picked up and going into the bag. So this is basically real life captioning, and you can also do detection. Find the spatulas. So you can have your robot, and you can tell it like, oh, grab, like move towards the hand, so you can detect that on that as well. And yep, let me share the link for this one. Oh, it works on video. Yes, it also works on video, but it also works on images. Actually, something really cool that I've been trying to do for a while is do some of those LLM robots where you ask the robot to do something and then the robot does that. I know there's some couple startups that are doing that right now. I know it's not really that hard to do it, but I guess I haven't had time to do those projects with everything that's been going on. But it will definitely be a really cool project to do, especially using Moondream. Moondream, I would say it's one of the key things that you want to do your autonomous systems. And yeah, they actually changed their page a lot. So we actually, my team and I, we found out about this model when they were like in baby diapers. So they were really unpopular, like no one knew about these models, and now they have over 8K GitHub stars. And yeah, so it has many capabilities. It has image captioning, then visual question answering in case that you want to answer questions from an image. Then it also has object detection to detect specific things on objects. It also has pointing. So if you want to point at something because you want to grab it or you want to identify something, then you can also do that as well. Then it also has gaze detection to know where the person is actually looking at. I have never tried this one, so it will be really cool to try it out. And then this is the one that this person was asking about detecting characters. So you can transcribe the text in natural reading order. And you can actually give it a query. So you identify things from an image and you transform it into text, which is really cool. And yep, they have they're really cost effective. You can get it running in minutes. You could run it yourself, or you can also run it on the cloud. And I think they're dropping their new model, Moondream 3 Preview. Level reasoning. Let's see what they have. Runner with purple socks. Wow, that's interesting. And it has like the different detections of why Moondream is better compared to other models out there. Quantity input. What is this? Oh, it detects like the input from an image. So for example, quantity input, and then this one is not. This others are not detecting correctly. Damn, this is really nice. Moodle supports pointing as a native skill. This is really cool. Best utensil for pasta. Wow, honestly, this is impressive. This is a new model that they are basically just dropping, Moondream 3. So I can't wait to use this. Generates intelligence structure with minimal prompting. Let dogs, and you can actually ask it to give you an array. And then there's the OCR part, where you can use vision encoder and get tripped up on any tiny fonts or whatever to make it useful and convert this to markdown and stuff. Then they have their benchmarks in here. Mm, okay, this is nice. This is nice. So let's go back. Okay, so now that you know the things that you can do with Moondream, I think we can actually try it out. So let's go to see it in action. So this is sort of their playground. You can also use it directly. Let's go first by using some of the images that they have. And you can, for example, type a question like, what is this? And then it will basically tell you what this is. The image shows a receipt from Main Street Restaurant. And then, oh, this is cool. You can actually show the code to test it. Nice. And you can also do a curl request. And let's see, for example, point, and let's give it point for point at the order ID. Let's see if this happens, if this works actually. This is not the order ID. It got it wrong. And then, for example, let's actually upload one of our images. Can I upload my image? Yep. Let's upload the food image in here. And let's tell it query, give me a JSON with all of the food elements you see on the screen and their category as well. Okay, so it has grilled ribs, pretzel twists, salads, pickled vegetables, marinated meat skewers, quiche, bread rolls, sauces. This is nice. And let's now try to detect, um, let's detect salad, for example. It detected everything as a salad. That's super bad. Let's try with something more specific, meat, for example. Okay, so it detected meat fairly nice. Then let's try with sausage. No objects detected in this image. Let's try with a plate. Okay, this is nice. There are some plates in there, so I'll give it that. Awesome. So basically, with this, we are testing what Moondream can actually do. As I was saying, this is a playground. You can actually go ahead and interact with this. Let me share this one with you on the chat as well, so you can play around. And now that you see all of the cool capabilities that it has, then you can apply those capabilities into your projects. So if you go into API keys, you can log in with your account and get your free API key in there. So you can start creating. And then you can also view the API documentation in order to test all the different things that they have. And you can also see some of the sample projects that they have with examples. Hello world example using basic model usage. So we can go ahead and see all of the examples and we can try running some of those as well. So let's see, quick start. And then we can go to Python. We can go detect cars, for example. Oh, what's the main? Mm, yeah, we can actually go ahead and try this one. So this one runs the model locally, or we can also use a cloud version and you load the image and then you can generate the caption or you can generate the detection or whatever you want to generate. So let's go over here and create a new one called OneDream .py. Let's copy paste this one. I'm not going to run it locally, so I'm going to comment this and I'm going to run it with the API. So let me just fetch one free API from the dashboard over here. Let's go to, let's go back. Oh, whoops. Start coding, Modern Cloud Console, and create API key. Copy, I've saved my API key. Awesome, and then I go back, I just paste this in here. I don't mind. I mean, I'm not going to push this or anything, so I'll just drop it in there. And let's pass it the image of the plushie. I'm actually interested into what the caption will be. So in this case, it will generate a caption. So let's see what that caption is from this image. So let's run this now. It's Python moondream.py. Oh, I need to install Moondream. Wait, no, Moondream is actually installed. Oh, I think this happened back then. That it doesn't support this one. So let's see if there's an update for this. pip install Moondream. Uh, Wait, what's the actual definition for this? Let's see, usage. Wow, it not actually tells you. You know, back then this was completely free. There was not even a dashboard. There was not even like the billing thing. Wow, this is not cool. I think the Moondream people found out that this was really cool. So now you can actually have credits in here. Mm, this is not cool. But I mean, I guess they had to make money somewhere, you know. Let's go to the quick start. So we already saw Moondream examples from here. Mm, what if we actually? I'm going to go ahead and start this. What are images? Cars. Model. This is how to run this. Python, Modrum locally using Modrum Station. This is the one that you can download in case that you want to run it locally. And yeah, I guess that's everything. Uh, Copy and paste your API key, include your API key in the request, send your request using JSON format. Let's see if from the playground, um, we can actually get that to work. Mm. Or we can also do it locally, getting started. Why can't I find the Python package to install? Include your API key. Let's go and click in here. Playground, and then let's try this one. What condiment is visible? Got to show code. Mm, let's try this one from here. Or we can also try the pull request, I guess. Let's try this one. Um, let me change this one. Um, API key model. It's actually the same. Not sure why it isn't working with this one. Because I remember we had that issue back then with the BL that is not detecting that one. I mean, worst case, we can just do the cloud version on the playground to test it out, and we can. Here is it. What is in the image? That makes sense. Yeah, let's try this again. Let's see what happens. Or I can just try running it directly. Uh, Moondream has no attribute. Oh, it has to give with the name. Let's call it test. Yep, and let's just call it Moondream. There we go. Yeah, because the name of the file was the same as the library, so that's why it was happening. Um, the circular import thing. Let's try this again. Cannot open file. But now I don't have that one. Um, let's try this again. Oh, now there's a different thing in here. It says key error request ID. Huh? What is this? I don't. We don't even need this. Let's still leave this in here. Are you looking for this? No, the Moondream station. That one is to run it locally. I believe it's only. I can just look it up at the PAP library. But I have it installed because it's not marked in there. And yeah, now it's working. So it says the image features a plush toy resembling a cartoon character with black fur, tan face, and large brown eyes. The toy is positioned on a white shelf or table. In the background, a person is seated with a brown office chair and blah blah. And the image that it's describing, it's basically this one. So now let's try another feature. So let's try the object detection feature. So if we go back, let's see. Usage. Wait, where is the documentation? Let me see if I can find the detect one. So for detect, let's do detections. We can actually try this one. Let's copy paste this. Whoop, it's too much to detect the object. You know what? I'll just copy paste everything. Here we go. And then let's paste it down here. And let's delete this one because we already have it. Let's move these on the upper side. Model, image, we don't need this one. And now let's try to detect plushie in here. We don't need request ID. Let's do plushies in here. And request ID, we can just delete this. Okay, so this is just to do the image in here. Output with detections and plushie is correct. Okay, so hopefully in here it will be able to detect our plushie. Let's see if that happens. Let's see. Found one plushie. Oh, I think I forgot to change the label. There we go. So it detected one plushie in here. And now I can actually change the prompt in here. Let me just change this one to object. For example, if I trace glasses, let's see if it can actually detect the glasses that the person is wearing on the image. So let's run this again. Yeah, and it was able to detect the glasses in here, which is really cool, to be honest. Moondream 3 requires NVIDIA GPUs with 24 gigabytes of memory. I guess that's not cool at all. That's weird. I mean, I didn't read it carefully, but maybe they also have their cloud version where we can run Moondream 3. Like for example, this one I'm running it through their cloud API. So maybe for Moondream 3 they can also run it. We can also run it from the at the moment. Oh, okay. Yeah, hopefully they will launch it for everyone. I mean, not only for people that have like super nice um, graphic cards, because that will be nice. Any more comments? Oh, it works on video. Okay, great. So in here, it was able to detect the glasses. And if you see, the image is honestly not really good, so it's also blurry. And it works similar as YOLO-E. And for this one, you can also try the OCR um, part where you can actually detect, for example, captions of a video. So you can give it a video or an image and it can actually caption it. Or you can also do pointing, where you point at something, detection to detect the object, query to ask a question to your image. And here's just an overview of some of the simple things that you can do from there. Awesome. So hopefully with that, you are able to take a have an idea of how Moondream works. So now if we go back to our slides presentation, just to wrap up with some simple concepts in here. So you want to use Moondream if you need natural language descriptions of images. So if you want sort of a prompt answer um, thing for your application, and then if you want to interact with Q&A about visual content. So for example, if you are using a chatbot or you want to give descriptions from what your robot is seeing, then that's also completely valid. Or in case that you want to build an AI assistant to reason about specific images. And then you want to use traditional computer vision tools. So for example, regular YOLO, if you need high precision detection and segmentation, if you require actual real-time processing, or if you're working on low-level image processing like filters or edge detections, then you might want to use OpenCV. So this is a nice comparison of both models and how to use them. Again, both YOLO and Moondream are completely open source. So you can definitely go ahead and search their GitHubs and look at their projects to see them more as well. So right now we were basically testing the Moondream API. Again, I think you have those $5 a worth of free credits. Before it was completely free. So I guess they're trying to make it more profitable for them. Yeah, this is just an example of what an API is. I guess I won't be going into that today. I guess I just forgot to delete the slide. Awesome. So that was basically it. for our stream. I'll be sending the slides now so I don't forget. There we go. And then I also send the documentation for all the two computer vision models that you were using. I'm also going to share this other link for you to submit feedback on the stream. So if you want to see something on a global hack week, or if you want to provide feedback on the stream, please fill out that 3 minute survey. I think you can take like up to 2 or 3 minutes to fill that survey over there. And yeah, if there's not any more questions or comments, then I'll be logging off for the day. And yeah, I guess I'll see you tomorrow for our second stream, which will be about Ross. I'll actually see if we can do a cool project from there, but we will mostly get a lot into the technical details about how it works and also see some examples in real time. Awesome. So I'll see you tomorrow. Make sure to tune in for the rest of the Global Hack Week. I think that for the day, we there's another stream happening tomorrow morning about MCP servers. So definitely make sure to tune in for that one, and then have yourself be yourself prepared for day 3 of Global Hack Week for open source. Thank you again, and I will see you tomorrow. Bye, everyone.